write down solving rational equations. This is our first lesson in this class for 2024. Now notice we're working with equations. We're not working with expressions. Here's our very first equation that we are going to solve. And before I start to solve it, I do need to remind us of an important rule as it pertains to fractions. Remember that we're breaking a math rule if we ever end up with 0 in the denominator. So here's example number 1. The very first thing I'm going to do is I'm going to identify what x cannot be. So I'm going to look at the denominators of all three terms. If the denominator does not have a variable, I get to ignore it. So I ignore, but this has a variable in the denominator. So I'm going to set it equal to 0, and I'm going to solve. What this does is it's able to identify what x cannot be. And you may be confused by this. If I take -3 and I plug it in here, -3 plus 3 is 0. I'd have 2 over 0. We can never have 0 on the bottom of a fraction. That means I'd be breaking a math rule. So after I get done solving, I always want to come back and make sure that whatever I get for an answer does not equal this identified number. There's different ways for us to solve this. This standard says algebraically you need to show how to solve it. I'm going to teach you using the LCM method for this particular type of rational equation. I look at the denominators of the second and the third group, and I'm going to write down multiples of 2 and of 10. 2, 4, 6, 8, 10, 12, and so on. And multiples of 10, 10, 20, 30. And I'm going to identify the smallest multiple that occurs in both groups. That would be 10. The smallest number that occurs in the multiples of 2 and the multiples of 10 is 10. So when I identify the LCM, which stands for least common multiple, 10 is going to be one of the numbers. The next thing I'm trying to do is I'm trying to achieve the exact same value on the denominators of all three terms. I also need the group x plus 3. This is what I'm going to achieve by transforming the original equation. So I'm going to come up here to this first term, and I'm going to write down 2 over x plus 3. Now it has the x plus 3, so I'm going to put a check. Awesome, it has the x plus 3, great. But it's missing a 10. So to this very first term, I'm going to attach a 10. Whatever you attach to the bottom or the denominator, you must also attach to the numerator every single time. So this first term, it now has a 10, and it has the quantity x plus 3. Great. Let's transform the second term, or the second fraction. I need to achieve a 10, and I have a 2. We can't transform the 2 into a 10 by adding 8. You can't add or subtract to transform it. You can only multiply or divide. So 2 times what quantity is 10? 5. So whatever I multiply by the denominator, I must also multiply in the numerator. So I have the quantity 10. Now I need to have an x plus 3. So I attach an x plus 3. All right, let's go on to the last term. The last term has a 10, but it's missing an x plus 3, so I attach an x plus 3. Whatever you attach to the bottom must be attached to the top. The next step is to ensure that we have a 10 times x plus 3, 10 times x plus 3, 10 times x plus 3, 10 times x plus 3. Now here's the cool part. When we're working with rational equations, we get to wipe out the denominator once they are exactly the same, and now I'm going to solve the numerator using the skills you learned freshman year. So 2 times 10 is 20, plus 3 times 5 is 15, equals 19 times x plus 3. I'm going to solve this by distributing the 15 and the 19. 20 plus 15x plus 45 equals 19x plus 57. And now let's combine like terms. 20 and 45 is 65. And you have a choice whether to move the x's to the left or right. It's up to you. I'm going to move the x's to the right-hand side. You could have moved them to the left, and you can still achieve the same answer. So I got an answer of 2. Now, I don't know that for sure that's correct, but I got an answer of 2. I check. Okay, it's not -3, so that's a good thing. Take your calculator and please do second plus 712. How do we do that? You're going to hit the blue button, and then, so that's the second plus 712. We're going to clear the RAM. Now, I'm going to show us, the standard says that I have to grade you based on your algebra, but we're going to show how we can use technology to ensure this is the correct answer and that we eliminate any type of extraneous solution. So I'm going to come back up here. Y equals. Notice that there's a left side and a right side to this problem. This is the left side. This is the right side. The left side, I'm going to enter into L or to Y sub 1. The right side, I'll enter into Y sub 2. So here's my first part. Parentheses. Parentheses are very important. 2 divided by, okay, there's more than one quantity, so I'm going to put in parentheses, x plus 3 plus 3 divided by 2. That's the left side to the equal sign. It goes in as L sub or Y sub 1. Now I'm going to go to Y sub 2 and I'm going to enter in the right side of the equal sign, which is 19 divided by 10. I'm going to graph these two functions by hitting graph, and I'm going to use the intersect function to find out where do they intersect. So I can see it looks like they intersect right in here. We learned how to do this in August. Second, trace and go down to intersect, and I'm going to press enter 3 times. Enter, by the way, is in the bottom right-hand corner. 1, 2, 3, and my answer for the x, that's what I'm trying to solve, is 2. As long as this answer matches this answer, we know we correctly solved the rational equation. This is example number 2. So I see 3 different groups called terms. There's 3 different terms here, but I only see a denominator for the first term and the third term. If you don't see a denominator, always put a 1 underneath. If you don't see a denominator, always put a 1 underneath. Okay, the next thing is I'm going to look at the denominators, and if there's no variable, I get to ignore it for the time being. No variable, ignore. Oh, this has a variable. So x minus 2 equals 0. I solve it. This means x cannot equal 2. X cannot equal 2. Why? If I substitute 2 into this first term, 2 minus 2 is 0, and I have 5 minus 0, we can never have 0 on the bottom. All right, now we're going to determine what is the LCM. So I look at the 2 terms that have no x, and I write down, and you could do this in your head. I'm just visually showing you how I do this. So I'm going to do multiples of 1. 1, 2, 3, 4, 5, 6, 7, 8, 1, and multiples of 6. 6, 12, 18. What is the smallest number that occurs in both lists? 6. So 6 is going to be the part of the value for my LCM. The other part is this group x minus 2. So this is my LCM. This is what I want to achieve in the denominator of all 3 terms for me to solve this. Let's look at the first term. I have 5 over x minus 2. What is the denominator of the first term missing? It's missing it has an x minus 2, but it's missing a 6. So I'm going to attach a 6 to both the denominator and the numerator. Make sure you're whispering back, please. The second term has a 1. I cannot achieve a 6 by adding 5. It has to only be achieved by multiplying or dividing. So I'm going to multiply by 6. Now I have 6 in the denominator, but I need to also have an x minus 2. So I attach an x minus 2, and whatever you attach to the bottom, you must also attach to the top. All right, my last term, I have a 6, but I need to have an x minus 2 as well. So x minus 2 and x minus 2. Now I'm just going to glance here. 6 times x minus 2, got it? 6 times x minus 2, 6 times x minus 2. Now I get to wipe out the denominators, and I only have to solve the numerator. 6 times 5 is 30. 2 times 6 is 12. And 17 times x minus 2. Just like example number 1, I'm going to distribute the 12 and the 17 next. And I'm going to combine like terms. 30 subtract 24 is 6. And you can choose to move the x's to the left or to the right. It is up to you. I believe that x is equal to 8. What does that even mean? It means if I took this value and I plugged it back in here, I better get a value on the left that is equal to the value on the right. And we're going to use the calculator to justify that this is the correct answer. But first I have to make sure that 8 is not equal to 2. I'm good. Grab your calculator, please. Do second plus 712. In the first, in y sub 1, I have 5 divided by, I'm going to put an extra parenthesis on the bottom, plus 2 divided by 1. Y sub 2 is going to be 17 divided by 6. Then I'm going to graph it and find out where they intersect. Okay, so what I'm going to do now is I'm going to hit graph. Let's find out where they intersect. It looks like they're going to intersect right here. Second trace, intersect. And I'm going to move my cursor. And I'm going to do enter, enter, and enter. And I can see that it says intersect at 8. I thought the answer was 8 with the algebra that I provided you. And I'm able to now justify, yes, the correct answer is 8. This is example number 3. So we are only focused on the denominators. Now, I suggest that students, when they first start, put parentheses around the x minus 2 and the x plus 4. I'm going to take this portion, and I want to see if I can take this off to the side and if I can rewrite it. When we rewrite it, we are able to factor it. So what multiplies to equal -8 and combines to give you 2? You've had like 2.5 weeks off. What two values multiply to equal -8 and combine to give you 2? Maybe it doesn't exist. What two numbers multiply to give you -8 and combine to give you 2? Though it would be 4 and 2, but the signs matter. Okay, so 4 times 2, to get a -8, one of them has to be negative. But remember, they have to combine to give you a +4, or +2. So +4 and -2. Multiply and combine. And because the leading coefficient is 1, I get to rewrite this as x plus 4. It's simple, and x minus 2. I'm going to lightly cross this out because I know x squared plus 2x minus 8 is equivalent to this expression. Okay, here's our next thing. So this is what we have so far. Now our next thing is going to be to rewrite it. So let's find that LCM. LCM. Okay, I can see that we want to have a group of x minus 2 and we want to have a group of x plus 4. We want to have a group of x minus 2 and x plus 4. Okay, so I'm going to multiply this times x plus 4. And multiply this times x minus 2. 1 times x plus 4 is x plus 4 over x minus 2 and x plus 4. X plus 4 and x minus 2. Now the denominators are all the same, so I get to cross them out. I'm going to give you 90 seconds. I want you to solve the numerator. Ready, get set, and begin. Solve the numerator. Okay, so I have x plus 4 equals 2x plus 1. Oh, and I already see my mistake here. I see my mistake. When I multiplied 1 times x, I should have been vocal with you. 1 times x is 1x, and 1 times 4 is 4. So some of you may have wondered what happened to the 1. Well, I've already distributed, just so you understand that. Okay, then I have 2 times x is 2x, and 2 times negative 2 is negative 4. All right, what can I combine here? Well, 2x and 2x is a 4x, and 1 minus 4 is a negative 3. Let's move the x's to one side. You have a choice to move them to the left or to the right. X equals 7/3. Okay, so x equals 7/3, but I need to know, what is 7/3 equal to? Now, in my mind, I'm quickly going, okay, 3 goes into 7, a maximum of 2 times. Okay, so I'm thinking 2 1/3, but we can quickly take our calculator, and let's just press clear for a second, and we can go 7 divided by 3. So I think my answer for this, if I did the math right, is about 2.3 repeating. But let's use the calculator to make sure we did this right. Do second plus 7 1 2. And I'll show you, I made a mistake when I originally practiced this problem by not using enough parentheses. So please pay close attention here. I'm going over what is the original. So on the left-hand side, I have this. On the right-hand side, I have this part. So please follow along with me. Don't jump ahead here. We have 1 divided by, and in parentheses, it's x minus 2. That is the left-hand side. Okay, now let's look at the right-hand side. On the right-hand side, this is the tricky one. So because there's more than one term, I need to put an extra parenthesis around 2x plus 1 divided by, the original was x squared plus 2x minus 8. And then I still have to add the second parenthesis, plus 2 divided by x plus 4. And now I can graph it, and let's see where it intersects. So it appears to intersect in this region right here, where it almost looks like they're over the top. I'm going to go second trace, find the intersection, and I'm going to move to that side where it appears to intersect. Enter, enter, enter. Oops, sorry, here. I did it one too many times. Enter, enter, enter. Here's my answer, 2.3 repeating. And remember, we already determined that 7/3 was the same as 2.3 repeating. All right, number 1. So the first thing we're going to do as we look at number 1, is there a denominator for all 3 terms? Yes or no? Is there a denominator? The answer is no. The first term has a denominator, the second term has a denominator, the third term does not, so we're going to put a 1 at the bottom. That's step 1. Step 2 is, let's look at the denominator of all 3 terms. And if it has a variable, we're going to set it equal to 0. So I can see that in number 1, the only variable that exists is in this position. So I'm going to set that equal to 0. There's no work that has to be done. And I want to identify that x cannot equal 0. So when we get done with our problem, we need to make sure that it is not equal to 0. Why? Because 0 would be in the denominator, and we cannot break that math rule. Okay, the next thing we're going to do is we're going to take here, and we're going to find the LCM. So I could write down a list of 1, 2, 3, 4, so on, 5, 6, 7, and a list of 2s, 2, 4, 6. The first number we see in both lists is 2. You don't have to write that down unless it helps you. You're welcome to do that in your head. So 2 is part of the LCM, and we have a single x. This is what I want to achieve in all 3 of the denominators. So we're going to get started. We have 3/2. That's the first term. So it has a 2, but it's missing an x. So we're going to attach an x to the bottom and to the top. Plus 1/x. It has an x, but it's missing a 2. So I'm going to multiply by 2 to the top and to the bottom. And in our final one, we want to raise it to a 2x, and it only can be done by multiplying or dividing. So I can't go plus 1. I need to go times 2 and times x. Now I have 2x, 2x, and 2x. Awesome. The denominators are all the same. Let's wipe out just the bottom. And we have 3x plus 1 times 2 is 2. 2 times 2 times x is 4x. Please solve at this time for x. You have 30 seconds. Begin. All right, so I'm going to subtract 3x. 2 equals 1x, divide by 1, x equals 2. It's not equal to 0, but I still need to check and see, is that correct? So we're going to grab the calculator. I'm going to zoom out here. You're doing the same with me. We're going to go second plus 712. And now I'm going to plug it in. So 3 divided by 2 plus, parentheses, 1 divided by x. That's on the left side of the equal sign. I'm going to input it for L or Y sub 1. And then we have 2 divided by 1. Let's graph it and find out where do they meet. Okay, this is where I can see that it's going to intersect. So I'm going to do second trace intersect, moving it over, enter, enter, enter. My answer is 2. I just proved that we got an answer of 2. You cannot just do this and say, oh, x answer is x equals 2. You need to do this and then support your answer by checking. We're going to go on right now to number 2. We're checking on number 2 right now. Now, number 2, I do not see a 1 underneath the x or the 4, so please place a 1 there. There is only one denominator that has a variable. It's right here, so I'm going to set it equal to 0. That means x can never equal 0. Now, let's identify the LCM. Well, we want to have a 1, and we want to have an x. This is what I want to achieve in all 3 of the denominators. So I have 3 over x. I could multiply by 1, but multiplying by 1 doesn't change anything. Doesn't change anything at all. So there's your 1x plus x over 1. In the denominator, I want to have a 1x. So times x equals 4 over 1 times x times x. So I have 1x in the denominator of all 3 terms. Once I'm able to achieve that, I get to wipe out the bottom, and now I have 3 times 1 plus x times x equals 4x. Now, although we can move this to the left or right, it's always going to be my suggestion to move to the side that has an x squared. So let's move the 4x over. Now, there's nothing left on the right-hand side. On the left-hand side, if I write these in standard form, it looks like this. You're welcome to use the quadratic equation to solve or factoring if it works. Let's see if factoring works. 1 times 3 is 3. Can we think of 2 numbers that multiply to equal 3 and combine to equal -4? -1 and -3. Let's check. Multiply and combine. I love it. Because the leading coefficient is 1, it's x minus 1 and x minus 3. So I'm going to set each one of these groups equal to 0 right now, and I'm going to solve. Okay, so I think one answer is 1, and I think another answer is 3. Well, the good news is neither one of these answers is 0, but I don't know if they're the correct answer. How I'll know is I'm going to plug it in. This is a tool that's going to eliminate any extraneous solutions. So I'm going to clear my calculator. I'm going to go, whoops, sorry, second plus 712. I'm going to go to y equals, and I'm going to type this in. So the first one is 3 divided by x plus x, and now on the other side of the equal sign is 4. I can see I have 2 areas where they intersect. Second trace intersect. Let me move this down here. Okay, enter, enter, enter. Okay, one answer is 1. That means this works. Let's try it again for the other intersection point. Enter, enter, enter. My other answer is 3. That means this also works. What I want you to do for homework right now, this is the required work, is put a star next to number 3, put a star next to number 5, now flip it over, put a star next to number 10, and also write a 1 underneath the 3x and the 5 so you're not confused, and put a star next to number 11.